So what we're going to look at today, like everything we've done so far has been two lines that have crossed. So we've always had one point of intersection because you'd have one line going like this, and maybe a line with a negative slope. And of course, they have a point where they cross, and that's the solution that we've been getting. But sometimes you could have no solutions. For example, if one line was like this and the other line was parallel, they'll never cross. So if you tried to solve that, what would happen? What would happen when you're looking at that if they never cross? Also, we've seen in other units, you have y equals mx plus b as one form, and you have ax plus by plus c as another form, but it could be the same line. So what if you had a y equals mx plus b, and you graphed it and it looked like this, and you had another one in point slope form or general form, and you graphed it and it was exactly the same line? How many times do those lines intersect? A bunch, an infinite amount of times. So that's what we're looking at here, that often you're going to get you're going to get one solution, you're going to check to see if you got it right. But sometimes you're going to get two lines that are parallel, and sometimes you're going to get two lines that are exactly the same. If the two lines are exactly the same, you're going to get what happens in part B. You're going to solve and you're going to get something that's always true, like 0 is equal to 0 or 5 is equal to 5. And if it's always true, then you know that you would have an infinite amount of solutions. Remember I mentioned that before, that if you accidentally use the same line with substitution, that if you know how we have equation 1 and equation 2, and you solve for y or solve for x to get it by itself, then you have to substitute that into the other equation. And I said in class, if you substitute it back into the same equation, you'll get 0 equals 0 or 5 equals 5 because they're the same line. But sometimes you'll have two lines that when you substitute into the other one, it still gives you 0 equals 0. Then you know you'll have an infinite amount of solutions. And if you get something that's not possible, like 0 is equal to 4, negative 5 equals 3, then you're going to find out that those two lines were parallel and they never intersect. Okay, here is our first example. We have to find out if there are no solutions, one solution, or an infinite amount of solutions. And you have to decide which of your three strategies to finding a solution, elimination, substitution, or graphing, would be the easiest to use for this one. If you did use elimination, you could either eliminate the x's or the y's. In this example, can you see that the y's already have the same coefficient and they're opposites? So if we add these equations right away, I'm going to get negative x plus 0 equals 1, so x equals negative 1. Now you would have got the same answer if you would have multiplied by 2 to cancel out the x's. You would have got the same answers if you would have used substitution. Now that we've got x is negative 1, we can plug that into the first equation, add 1 to both sides, and you get y is equal to 4. So our solution is 1 point negative 1 comma 4. And I got the airplay going. I graphed it on my iPad. There's x plus y equals 3 and negative 2x minus y equals negative 2. And there, the two lines intersect at negative 1 comma 4. Obviously, they don't have the same slope. And because they don't have the same slope, we have an intersection point.